Section 7.5, Factoring a trinomial in the form x² plus bx plus c. When we say factoring, we're talking about the process in which we rewrite a polynomial as the product of two or more factors. We can always check our work after factoring by multiplying the factors together to see if we arrive at the original polynomial. For example, I claim that if I have the polynomial x² plus 9x plus 14, I can factor it into x plus 2 times x plus 7. X plus 2 is one factor, x plus 7 is another factor. To see if I've done this correctly, I can use the distributive property, the FOIL method, the box method, whatever way I want, to multiply these two binomials together and see if I arrive at my original polynomial. If I do this distributive property process, I'll see that what I will arrive at is x times x, which is x squared, plus 7 times x, which is 7x, plus 2 times x, which is 2x, plus 2 times 7, which is 14. Then certainly I have two terms in the middle that are like terms that can be combined, and I end up with x squared plus 9x plus 14, which is what I started with. Because these are the same, that means that I had originally factored correctly. X plus 2 times x plus 7 is the factored form of the polynomial x squared plus 9x plus 14. Now it's time to learn how we arrive at that solution. Let's first look at an example in the form x² plus bx plus c when c is a positive number. What I'm going to end up with when I start with x² plus bx plus c is two binomials, x plus p and x plus q. And what's going to be the case is these two numbers here, p and q, are going to add to equal the middle coefficient, b, and they're going to multiply to equal the constant term c. Now when c is positive, p and q have the same sign as b here, the middle coefficient, the coefficient of the term that just contains x. That means that if the middle number is positive, p and q will both be positive. If the middle number is negative, p and q will both be negative. Let's look at a couple of examples. The first one is x² plus 5x plus 6. Based on the rule that I've written up here, I know that this is going to look like one number, like x with one number and x with another number. Now, because c is positive, as you can see here, c is positive 6, I know that both the number that goes in the first binomial and in the second binomial will have the same sign as the middle coefficient of positive 5. That means I'm going to have pluses in both of these. Once again, the fact that this is positive means that these two things have to be the same as this symbol here. That's why they're both pluses. Now to fill in these numbers, I need to think of two numbers that are going to add up to the middle coefficient of 5 and multiply to the constant term of 6. Well, the only two numbers that both multiply to 6 and add up to 5 are 3 and 2. And so I can put those in either spot. Put the 3 first and then the 2. If I want, I could use the distributive property. X times x is x squared. X times 2 is 2x. 3 times x is 3x. Combine those last two to get 5x. And 3 times 2 is 6. That way I can check my answer. But this is indeed the factored form of my polynomial. Let's try it again with another example. X² minus 8x plus 12. once again, our constant term c is positive. So I know that when I factor this into two binomials, both starting with x, the signs have to be the same as the sign on my middle coefficient, the term that contains just the x. So since that's a negative, I'm going to use two subtractions. Now, just like I did before, I have to come up with two numbers that multiply to 12 and add up to 8. Now, the numbers that multiply to 12 and add up to 8 are 6 and 2. So that's why a 2 is going to go here and a 6 is here. You could do it in the other order, but that's the way that I've chosen to put it here. Once again, use the distributive property to check. This time, because we have a negative 2x and a negative 6x when we do part of our FOIL process, we end up getting the negative 8x that we want. By checking our work, we can be sure that we have correctly factored this polynomial. Now it's time for you to try. Completely factor each of these trinomials after pausing the video and then check your work. Do you need a hint? Remember that in each of these trinomials you're trying to come up with the two numbers that are going to multiply to the constant term and add up to the coefficient of the middle term. Now it's time to reveal our answers. And there you go. X squared plus 10x plus 16 factors into x plus 2x plus 8, and x squared minus 8x plus 15 factors into x minus 3, x minus 5. In both cases, the positive value of the constant term c told us that the signs in each of the factored binomials would be the same. Specifically, they'd be the same as the sign of the middle term. That's why they're both pluses on the left and both minuses on the right. 2 and 8 add up to 10 and multiply to 16. 3 and 5 add up to 8 and multiply to 15. There you go. Let's take a look at what happens when we change c from a positive number to a negative number. We're still going to have the same general form of a factored pair of binomials, x plus p times x plus q. And once again, p and q are still going to add up to the coefficient of the term with the x, and they're going to multiply to the constant term. However, when that constant term is negative, p and q are going to have different signs. One is going to be positive, one is going to be negative. Looking at the examples below, we have x squared minus 4x minus 5. Now we do know that the factored form of this will be a pair of binomials, both starting with x. We also know, because the constant term is negative, that we're going to have one of these binomials be an addition and one be a subtraction. So now we just need to figure out what numbers multiply to negative 5 and add up to negative 4. Well, the fact that they're multiplying to negative 5 is represented by the fact that we have one positive and one negative. And really the only way to multiply to get 5 is 1 by 5. So we have to make a decision of whether to include the 1 in the first binomial and the 5 in the second, or the 5 in the first binomial and the 1 in the second. And what's going to make a difference is that we have to think about these two numbers as adding up to negative 4. Well, if they're adding up to negative 4, my options are a positive 1 with a negative 5, or a positive 5 with a negative 1. Based on those two options, it's pretty clear that I want the 5 to be the negative number, because it's going to be larger and cancel out the positive 1. So I don't want the 5 in the first, meaning I don't want the 1 in the second one. So the factored form is going to be x plus 1, x minus 5. A quick check will show us that that is indeed the correctly factored form of my trinomial x squared minus 4x minus 5. Let's use a similar process to figure out the factored form of the second one, x squared plus 3x minus 28. Once again, I know my starting point is going to be two binomials, both starting with x. The presence of a negative value for the c, negative 28, tells me I'm going to have one addition and one subtraction. Now I'm trying to figure out what numbers multiply to negative 28 and add up to 3. Well, since I'm multiplying to a negative number, I know one will be positive, one will be negative. Ways to multiply to 28 include 1 and 28, 2 and 14, and 4 and 7. Making one of those numbers negative, the only combination that will work in getting 3x is a 4 and a 7. And I just have to choose which spot they go in. So I have to check that out. I want to make sure that when I multiply out, I end up getting a positive 3x. That means that I need the positive number here to be larger so that it dominates the negative and ends up with a positive result. That means that the 7 must have to be in the positive or the addition binomial, and the 4 must be in the other. The factored form that I'm looking for is x plus 7 times x minus 4. Very easy to check, and that's going to be my factored form. Here are two examples for you to try. Make sure that you double check your work by multiplying the two factors together. The most common problems that people have with these are just putting the numbers in the wrong binomials, which results in the middle term having the opposite sign that it should have. Pause the video now, give it a shot, and then check your answers. Alright, time now to show the answers. And here are your solutions. The factored form of x squared minus 2x minus 3 is x minus 3 times x plus 1. The factored form of x squared plus 4x minus 21 is x plus 7, x minus 3. Down below, I've just shown what happens if you put the numbers in the wrong binomial or with the wrong sign, either positive versus negative. You'll notice that the outside terms are exactly what we want, but the problem is the inside term. This is a plus 2x, we want a negative 2x. On the right, we have a minus 4x instead of a plus 4x. That's the problem that we have there. That's just evidence that these are not the correct answers. So I actually would want to cross those off. Those are incorrect. You know what? I say we get some more practice in. Pause the video now, give these a shot, and then check your answers. Alright, let's find out how we did. How'd you do? Keep in mind that any of these answers could be switched around. For example, your first answer here could very easily be y plus 5 times y plus 8. All that matters is that you have the correct sign, positive or negative, with the correct number. If you're not sure how any of these came about, just double check all the rules that we've talked about so far. Time for a little word problem practice. Let's say a farmer plants a rectangular pumpkin patch in the northeast corner of a square plot of land. The area of the pumpkin patch is 600 square meters. So what is the area of the entire square plot of land? Well, based on this diagram, we can see that the original square is s meters on each side. And when we put in the pumpkin patch, the remaining dimensions are 40 meters on the top and 30 meters on the right. Based on these dimensions, we can say that the bottom of the rectangular plot for the pumpkin patch is s minus 40 meters. The entire length, subtracting just that little part that's left over, that's the s minus 40. And the height is s minus 30 for the same reason. It's the entire length, which is s, other than the 30 meters that are left over. So those are the dimensions of that rectangular plot. To figure out the area of the pumpkin patch, which is a rectangle, we just need to use the formula for the area of a rectangle, which is area equals length times width. In this particular example, our length is s minus 30, and our width is s minus 40. Since we are already told the area, 600 square meters, we can just plug that value in for A. Now we want to solve this equation. It looks like the type of equation we'd want to solve using the zero product property, but we can't do that because we have a 600 on the left side. That means we're going to have to distribute s minus 30 into s minus 40 and use either the FOIL method or the Punnett square method or any method that we can to multiply those first. When we multiply those out and combine like terms, we end up getting s squared minus 70s plus 1200. Now let's move that 600 over to the right by subtracting it so that we can apply the zero product property. By once again combining like terms, I get 0 equals s squared minus 70s plus 600. Now this is a prime candidate to be factored and then use the zero product property. Since I have s squared minus 70s plus 600, I know that my factored form is going to be two binomials with the same sign as the middle coefficient, which is negative. So this is going to be s minus something times s minus something. Now once again, I try to figure out what two numbers multiply to 600 and add up to 70. Well, if I try a couple of different things, I'll recognize that I get s minus 10 times s minus 60. Quick FOIL will show that that goes back to our original polynomial of s squared minus 70s plus 600. By using the zero product property, I would take each of these factors and set it equal to 0 and solve. If s minus 10 equals 0, that would give me the solution s equals 10. Meanwhile, if s minus 60 equals 0, that would give me the solution s equals 60. I want to look back at my original diagram to see if both of these answers make sense. If s equals 10, that would mean that this side of the pumpkin patch was 10 minus 30, or negative 20 meters, which doesn't make any sense. So I'm going to disregard 10 as a solution. If I do s equals 60, however, this side of the pumpkin patch becomes 60 minus 30, which is 30, and this side becomes 60 minus 40, which is 20 meters. That makes sense, which tells me that s equals 60 is my solution. But I want to make sure that I answer the question. What is the area of the square plot of land? Well, the area of this plot of land is going to be 60 meters times 60 meters because it's just a square, which has the same properties as a rectangle. The area is length times width, and in this case 60 meters times 60 meters is 3,600 square meters, and that's the area of this plot of land, which we solved by factoring a polynomial. I just wanted to show you one last thing. There are some problems that are going to frustrate you. If I ask you to factor x squared plus 5x plus 10, you would probably do the following. You would say, I know the right form. It's going to be two binomials, both starting with x. The final term, c, is positive, so both of the binomials are going to contain additions because the middle term is positive. So this is going to be x plus something times x plus something. Then you would go and you'd try to think of the things that multiply to 10 and add up to 5. Well, if you put together your candidates, the only two ways to multiply and get 10 are 1 and 10 or 2 and 5. Which one goes in which spot? Well, the problem is that whichever one you plug in, you're not going to get them to add up to 5x. If you choose the pair of 1 and 10 and plug those in, you'll end up getting 11x instead of 5x. If you plug in 2 and 5, you'll end up getting 7x instead of 5x. This problem can't be factored. This is the type of polynomial that can't be broken down into two binomial factors, and so we have a special name for it. We call this a prime polynomial. Just like when you have numbers that can't be broken down any further into any factors besides 1 in itself, a polynomial that can't be broken down any further is called prime. So if you run into a polynomial and you can't figure out how to factor it, don't be too frustrated. It's possible that it can't be done and that you're dealing with a prime polynomial.